we're going to move to our next presentation, which is going to be a training on the dredge material decision support tool by US EPA. And so our two presenters today are Kathleen Williams and Sebastian Paczuski. I got that right? Okay. Katie is an EPA researcher studying how individuals, organizations, and agencies are engaged in environmental management in the Great Lakes Area of Concern program. To understand these dynamics, Katie researches policies, learns about how different people use information and knowledge, and maps institutional processes. Katie was part of the team that designed the dredge material decision tool. And Katie has a BA in environmental science and physical geography from Carroll College in Waukesha, and a master's and PhD in geography from the University of Wisconsin-Milwaukee. And then Sebastian supports social science aspects of EPA's research. He analyzes community case studies, works with local natural resource managers on decision support processes, examines health impact assessments completed by EPA, studies the beneficial reuse of dredge materials, and supports the Pickle Pond Restoration Project. So it's very busy, obviously. Sebastian was also part of the team that designed the dredge material decision tool. And Sebastian has a bachelor's in international studies, specializing in the global commons and environment from the University of Wisconsin-Madison, and a master's of sustainable peace building degree, also from the University of Wisconsin-Milwaukee. So I will turn it over to the two of you, and thank you for being here.
Thanks, Natalie. So the team that developed this tool is they are Sebastian and Kiana Margison, which some of you might have met before, Rosita Clark and Carla Elker. They're from Region 5. They're actually the team that originally developed the tool, and then Joel. So next slide, please. So the way this tool started, it really started in Lake Erie. The idea was that it wasn't open lake disposal had been what was most often used, but it wasn't allowed anymore. So Region 5 really wanted to be able to think about alternatives to be able to use dredge material as a resource. So the real intention was that communities could use dredge materials, that they're in the Cleveland area. Carla is in the Westlake office in Ohio. And so what are some of the uses in Cleveland that could help inform how other communities might be able to use the tool? So that's where this tool started. And the idea was to really use the three-legged stool, environment, economics, and social benefits. What can those pillars tell us about how dredge material can be used? Next slide, please. So in 2017 and 18, Region 5 and Ohio stakeholders held workshops and brainstorming events about dredge materials. 2018, there was an initial draft of the tool. In 2018, Region 5 began working with the Great Lakes Toxicology and Ecology Division here in Duluth. And so our job was to refine the tool and to create methods that would make the tool more usable, because the original tool was an Excel spreadsheet. The tool is still an Excel spreadsheet. However, there are a number of other materials now that make that spreadsheet more usable. And then we've conducted participatory research. So I also want to say thank you to the HTAC dredging subcommittee, because you guys are the ones who really helped us work through what this means, and we couldn't be here without you. So next slide. So the way this tool is designed, it is not prescriptive. So there isn't that you plug in everything and it spits out this much material should go in this place. What the tool is it is more of a facilitation and organizational tool. We used user-centered design. That meant that we worked with the people who would use the tool to refine it. But even before that, we did a lot of ethnographic research. So we studied the decisions where dredge material had been used. We found out, you know, when was dredge used, how was it used, what were some of the opportunities, what were some of the constraints, and that's how the tool was defined. The method is flexible, it's designed to be iterative, and because we tested it with users, we have a lot of confidence that it does work the way it's supposed to. Next slide. So the idea is to compare multiple projects based on multiple criteria. So when there is an environmental change, we always expect that it is positive, but sometimes it's negative, and we want to be able to capture that in this tool. So that way we can capture the direction of change. So also when we talk about change, we don't necessarily think about how big or small the change is, but the tool is designed to help gather that information as well. And also how certain, because sometimes when you're going through large amounts of information, sometimes you have, you know, you're using best professional judgment, sometimes you're really sure what's going to happen, but sometimes you're not as sure. And that is the, oh, can we go back for just a second? So the idea behind the tool is to create a common set of facts. Also, criteria can be weighed to reflect the importance. So for some agencies, you have priorities, and some of those priorities are very important, and you want to be able to put your thumb on the scale for the priorities that are most important. There are options in the tool to do that, and because the dredge tool itself, the way the math is calculated is on an Excel spreadsheet. There's a pile of worksheets that help make the tool more useful. Next slide, please. So the way information flows through the tool is that you start by gathering everybody together. So this is your stakeholders, your community, all of the agencies, because everybody has a different piece of knowledge when it comes to dredge. There are, you know, lots of different types of knowledge, lots of different types of responsibility, and you want to be able to bring all of that together into a collective decision. So that's why you gather your information and stakeholders, and then you complete the worksheets. And so that's a couple of the steps. And what the worksheets do is they help you get to that common set of facts. This is what we think is going to happen at these sites. So then you move on to the scoring step. And that's where you take all of the information from the worksheets and then you put it into the scorecards. And the scorecards, they're Likert scale 1 to 5, but they're based on these facts. And then after you put everything into the scorecards, then you can review the results. Then you go on and you adjust the weights and the criteria as necessary. So a lot of you filled out the weighting exercise. That's actually in this step where that would go. And so then you evaluate the results. So the tool in a lot of ways, it's organizational and it's evaluative. And so one of the exciting things that was talked about earlier in earlier discussions about the tool is that it can also help identify some of the holes. Like, we think this would be great, but we don't have this bit of information. So maybe that is some of the experiment that will be done today. Next slide. So when it comes to dredge material, there are lots of different impacts. You're making environmental changes. There's a lot of economic considerations. One of the things that when we were doing the, when the original version of the tool, it did have a lot of the biophysical environment, the social and the economic, but they were the costs, they were things that, oh, well, there would be more bird watching. And then there were some the biophysical environment changes. But the reasons that most people make decisions actually fall in this category, in the governance. And so one of the things about this tool is it takes all of the things that we want to happen, all of the benefits, the environmental, the social benefits, and balances it with the constraints, the costs, and the rules you have to follow. So that is one of the values of this approach. Next slide. So this tool was created here in the Twin Ports. So biophysical environment categories will hopefully look very comfortable to everybody in the room. So we looked at the type of habitat that could be created by using dredge material. It could be aquatic habitat, shoreline, river, wetland habitat, upland habitat. It was also really important to consider whether or not the habitat that's being created is some kind of priority. Does it fall in some category that has some special meaning to the collective, either a regulation, or does it fall in a special category in a plan? That was an important attribute to capture. So also restoring native species and reducing invasive species. Because these weren't the same, they were broken out as two separate categories. A lot of dredge had been used for stormwater management and control, and that is a biophysical environment change that was important, and also reducing contamination because it might be used as a cap. So these are the attributes that were captured in our research. This is not an exhaustive list. We are open to making these categories bigger if they need to be. So next slide. Economic costs and benefits. So have you secured funding? Or do you have an idea of where your funding is going to come from? Do you have an application prepared? Do you have partnerships? Do you have partners that maybe have been identified, but you haven't reached out to them, so this is something that's in process? Transportation. If you want to move dredge material, have to have a way to do it. Is that feasible? Project can accept. So the placement sites, it's really important for the Corps to be able to have sites that they know that they can put material. Is this a short-term or is it a long-term site? Will using material lead to some kind of business growth or opportunity? Are there some other benefits? Does it require long-term maintenance? So, I mean, this is something that is negative, but it's also something that's important to identify early. So, next slide, please. So governance. So dredge material is coming because you are maintaining navigation channels. But where might you use it? And so this is where you're starting to consider the rules of the dredge and also the rules of the placement. So does the site you want to use, is it in a voluntary program? Is it in the brownfields program? Do you have to consider environmental windows? Is it included in some kind of guidance documents? And this could be anything. For this particular project, it was always the AOC that the projects were in the AOC program. But this can be applied in to other contexts. Is the permit timeline reasonable? Are there zoning requirements? Do you have a contingency plan? Replicability was something that came up as something important. So next slide, please. And then social benefits. So when it comes to social benefits, I was really interested in Melissa's slide because I'd like to think more about what social benefits look like. That's one of the things that we study in our lab. And so the rainbow diagram is one of the ways that we think about how our environment contributes to health. When we think about health, we might think of individual factors and individual behaviors, but health is actually a lot bigger than that. It's when we have access to public services and infrastructure, that we have good living and working conditions, that we have fair social and economic policies. Living and working soil, water, and air quality is one of those living conditions that's really important, that dredged material can contribute to by improving park infrastructure, park access. There's potential for job creation. Using dredge material, you might be able to improve the aesthetics. Because decisions are complex and people have a lot of emotion, you might be able to involve the local community in a way that is meaningful. You can reduce exposure, improve ecosystem services, improve infrastructure, new infrastructure. And something that's important is that you'll notice that these categories are actually very general, and that's intentional because the tool is not prescriptive. These buckets are fairly big so that whatever the specific project alternatives, whatever the particulars are, they fit in this bucket. So that's one of the important, not just for social benefits, but for all of these categories. Next slide, please. And then we have the built environment. So in doing a lot of our research and testing, built environment was hypothesized as something that could benefit from dredge material, but there's also not necessarily a whole lot of evidence about how it's used. So this category isn't necessarily as big as some of the others. So yes, you can use it as a cap to reduce contamination and reduce risk of exposure. You can reduce the demand on borrow sources, provide a cap to create development sites or construction or parks and green space or site remediation. That was one of the big categories in Ohio. So, but this is one that definitely could benefit from more discussion. Next slide. So now that we've gone over what is in the tool, the next part we'll go over is how does this work? What are the steps that we take to go through these? So I'll go through the first two steps and then I'll turn it over, these two steps, and then turn it over to Sebastian, who will go through more of the mechanics of the tool. So first two steps are to gather information and to fill out the worksheets. Next slide, please. So what this is this is where you start to build that common set of facts. So you have your site name, you have your type of site it is, who the owner is, then all of your ownership information. You have all of the dredging information, where it's going to be, how much, where, the source, the soil type, and other soil types, how much it'll cost. And then there's more blanks as we go through. Next slide. Then, when we're talking about individual changes, that's where it really becomes important to think about what does the change mean. So, are you maintaining navigation channels? Yes. How likely are you going to do this? If you do this, there's a high probability you're going to maintain channels. So what is the magnitude of impact? You'll have a high impact because if you dredge the channels, you will open them back up. Direction. How does this action impact alternative feasibility? Makes it more feasible. So we get to go through all of those different criteria. Consideration of liability, enrolled in a voluntary program, able to be completed. And then there is a set of worksheets for each one of those five categories. Next slide. And then with that, I turn it over to Sebastian, who will go through all of the how-to.
Thanks, Katie. Hi, good morning. As Natalie mentioned and Katie mentioned, I'm Sebastian, and I've helped Katie develop this tool. So hi to those of you that are familiar, and hi to seeing new faces as well. Next slide, please. So as Katie mentioned, those profile and criteria worksheets help you and any partners to gather and record that shared set of facts that you could use to then apply the information to the scorecards so that you can enter scores into the tool for project comparison. So one of the versions of the decision tool is a Likert scale scoring version. So currently it's at one to five, five being the highest scoring and one being the lowest scoring score for a criterion. That can be adjusted, but we currently have it set on a 1 to 5 scale. So you can see here, this is an example of the social and governance category with scores recorded on it, and you would use those site profiles and criteria worksheets as references to fill those out, right? Then you can look back and see why did this criterion score a certain way. Next slide, please. We also have a binary choice version of the score sheet. So it's simpler, there's a little less differentiation between you know, the scoring for each criteria, and you know, it makes it a little easier to fill out. But yeah, also there's that a little less differentiation for each of the criterion. So this is an example of how you would fill out that binary choice scorecard. Next slide, please. And as all of you have seen, and some of you filled out as homework for this workshop, there's a scorecard for ranking the criteria. In order to use the Excel score sheet, you need to have the criteria ranked, because that's how the math works. There's a lot of different ways to do that. For the workshop today, we're going to be using an average of the answers we received, but yeah, there's lots of different ways to do that, and we can talk about that, you know, to consider different ways to use that moving forward. But this is, yeah, just an example of how you would fill out our criteria ranking scorecard on the worksheet. Next slide, please. So once you have those scorecards prepped, you're ready to move to this Excel spreadsheet, right? As Katie and I've mentioned, it's still in Excel, so that makes it flexible. You can do a lot of cool things with it. You can adjust it, but also, especially when you see it for the first time, it can be a little intimidating, right? There's a lot of cells. You could touch something that maybe you don't want to. We do have a manual online published with our report. So hopefully that provides a useful guide. We're always open to taking feedback and, you know, making that process of use easier. Next slide, please. So yeah, this is what the tool in default, how it's currently on our website looks like from a zoomed out view. You have to zoom out when you have a small screen, because this is how big it is, right? But on the left here, you have the categories that Katie went over and we looked at for the criteria worksheets and scorecards. And then each of the individual criterion are listed in their corresponding category. And then you have columns for the criteria ranking, some other columns that deal with percentile, which is just to show how some of the math is working, and also the weighting factor. And then like currently we have it set up in default to compare 3 projects at once. Today in this workshop, we are actually going to be using a version that allows us to compare, I think we have it set up for 9 right now at once, but it'll be in a much more viewer friendly way. So you guys will get to see that. But yeah, as I mentioned, this compares 3 at once. You have project information up there and user score entry columns here. Point calculation totals are in these columns next to those, and then these colored bars are actually just like a nice visual way to show how a project is scoring relative to the other projects in a certain category. So you know, it's on a scale of green to, I think, dark red, and a green category means that a project is doing really well, and a red not so well relative to the other projects that are being scored on the same sheet. Next slide, please. So yeah, this is a zoomed in focus of that upper left corner, just showing how you can enter some of the data to keep track of what it is you're looking at. Next slide, please. And this is a zoomed in view of the criteria categories and those user score entry columns. So you can see here's the criteria rank in column C. You can see here we just have it on like a numeric scale. I think we ranked them from 1 to 49 or so, however many we had at the time. And then these U columns are the ones where you enter the Likert scale scores. If you're using the binary tool score sheet, then instead there are just X's in a yes, no column. So you put an X if it's a yes, and you leave it blank if it's a no, and then the math calculates. The tool, I should mention, is dynamic. So anytime you enter something, it will change. The changes will be reflected instantly in the tool. So that's good in a way because you can see that it's working, but sometimes it's also a bit scary because something could change and you're not quite sure. You know, you have to change sometimes one thing at a time, and you need to wait for the end of your process to make sure that everything you know, is reflected the way it's supposed to be. Next slide, please. And this is just an example, again, since it's an Excel, it's flexible, you can do a lot of cool things with it. So this is just another way of kind of pulling scores out of a score sheet and comparing them. So you see like the green columns here are just reflecting the highest potential scores in each of the category sections we have. And then you can see listed at the bottom, alternative 1, alternative 2, and alternative 3 in different colors, and how each of those projects scored in those respective categories of comparison. Yeah, this is just one example of something you could do. You can also export, you know, do a lot of cool things. Next slide, please. Next slide, please. I think we're repeating some slides. Next slide, please.
It's going backwards.
Is it?
Yeah.
I think we're going backwards. Sorry. Perfect. Yeah. So yeah, once you have entered your scores into the tool and you get some of those outputs of results, it's time to talk about those results, make decisions, make adjustments, see if you've learned anything useful. And I think today we're gonna make an attempt at using some of those results as a base for prioritization of projects. So yeah, once you reach the decision step, next slide, please. So yeah, we have included the link for our EPA website that hosts some information about the DMDT, as well as links to the downloads for the manual and the tool and the other score sheets and resources that go with that. And also we have a database of beneficial use project examples as well. Next. Yeah, so yeah, in some, the decision tool explicitly considers benefits. It assumes that dredge materials are a resource. As Melissa described and as Katie described, that's kind of what we need going forward. The decision tool is also able to be modified. That's something we're continuing to work on in partnership with all of you as our partners. It's flexible. It's meant to benefit the user. So that's a big goal of ours. And yeah, it allows us to explicitly consider project details, program requirements and benefits at the same time. So, you know, it's a meaningful way of bringing that all together for user benefit. Next slide. So yeah, here's our contact information, particularly for those of you online, if you need to reach out to us or have questions that don't get answered today. And also there's a list of the rest of the EPA project team that worked on this. Again, a big thank you. I want to echo what Katie said for those of you that have worked with us before. You know, thank you so much. And for the new faces, thank you to you too, because you're going to be helping us improve it further. Thank you.
So for those who are in the room, the beneficial use of dredge material decision tool project report can be used as a resource. It functions as a user guide as well as sort of summarizing the process of coming up with the tool. We'll do a similar approach to Q&A as we did for Melissa's presentation. So we'll start with online questions, and remember to enter those into the Q&A box on your Zoom. And then we can move to questions from you all. So, go ahead, Madison.
Katie and Sebastian, we have one question online so far. This question asks, are separate worksheets filled out by each individual stakeholder and then somehow averaged in the Excel workbook? Do stakeholders ultimately have to reach consensus on criteria prioritization? So a little bit more on kind of individual versus group consensus on the worksheet.
So the answer is yes. And the reason is that it really depends on who is organizing. So one of the things you want to have is some kind of point of contact and some kind of probably project planning team. And then it's really up to the teams. So if there's a lot of contention, you might want to have everybody fill out their own form and then have somebody collect them and put them into a single sheet. That helps to make sure that everybody is heard. But then if you have a group where there's a lot of social cohesion, you might be able to do all of those worksheets together. And today, I think we're doing all of those worksheets together. So it really,
That's the goal.
that's the goal. So it's flexible. It's up to the user.
Thanks. No more questions online at this point.
Okay, so questions from in the room. We're gonna be using the tool, so if things aren't clear, it will be good to sort of get that covered. Go ahead, Jeff.
I was wondering about the number of attributes per category. And I noted your comment about like the social benefits has very general buckets. The biophysical environment has very, very specific buckets or attributes. And just looking at it roughly, those biophysical attributes are about, the number of those are about equal to all the rest of them combined. Does that inadvertently put a thumb on the scale for biophysical attributes or that category?
So yes, like there definitely is like a numeric weight to that for sure. And I think that's a reflection of how we're still working on getting a handle of, you know, the social benefits and economic benefits and stuff like that. But I think a benefit of how we're doing this, like with those categories, is that you can separate them, right? So, you know, you can pull out, like we're gonna have it sorted by category so that you can see, you know, a certain project might compare really favoritively overall because of the biophysical, you know, a lot of things that it does that way. But if it doesn't have as many benefits in other categories, like you'll be able to see that, right? And I think going forward, the goal is to add definitely to those other categories as well.
And does the weighting come into play then too?
It certainly can, yeah. Yeah, you guys will see what like the averages of the homework that was turned in was today. I think it's pretty balanced from what I remember from how that average numbers looked. So yeah, I mean, you'll see how it looks, and yeah, again, it's not prescriptive as well, so it's not like you need to select a project or prioritize one just because of, you know, a biophysical landslide, right?
And I have something to add to that. If you look at the list of all of the types of habitat in the biophysical environment, it's aquatic and upland, and chances are you're not going to have all of those types of habitat in one project. If you have an aquatic habitat project, the chances of you doing stormwater management, those two don't usually go together. So I think even though the biophysical category looks really big, you won't be filling in all of the boxes all of the time.
I think Willis, and then we'll go to you, Dave.
You notice that the scoring system is, well, 1 to 5 were all positive numbers, yet you acknowledge that some attributes may be negative. I'm curious as to why you didn't provide a scale on both positive and negative side of 0.
So mathematically, that's challenging and maybe it could be figured out. But the way, so in the way that we have it designed, something that's negative just scores poorly in a category. You know, so yeah, it doesn't subtract points from a project, but the project will lose points, like it won't score as high in a category.
So some are more beneficial and some are less beneficial, but none are degraded.
Correct.
Okay.
If, I don't know if that's. Yeah, I wouldn't say that you could assign, a value like degraded or not degraded to a criterion. I would say it's more or less beneficial.
The, you would capture that it's negative in the, where you're collecting the common set of facts. So the common set of facts and the math might be separate. They inform each other, but they're not necessarily the same thing. So you're capturing the knowledge that this is negative and it will score poorly on the criteria. So just because it's not negative in the math doesn't mean it's not considered as something negative somewhere in the process.
Go ahead, Dave.
Thanks, Dave, Grand Mesa, Wisconsin DNR. I'm curious about audience that this is designed for, and then just some thoughts you might have on implementing this type of tool to look at alternatives within a project design process and how that would be used to engage people in the community who might not have as much knowledge about how dredge material is used. So I'm looking around the room and a lot of the people are resource managers or people who are directly involved with dredge material management or have a fair amount of knowledge about it, but there's a lot of people in the community that don't. So just kind of some ideas there on how it could be used.
So one of the ideas behind this tool is that it increases transparency. So when you're talking, so one, the audience is agencies, definitely EPA, Army Corps, state agencies that are managing projects. I would say that you could definitely use it for different project alternatives because you could compare project alternatives, absolutely. When it comes to talking with the community, that's one of the things that we hypothesized that actually it was Sheree Hagan who said that we could possibly, that this looks like a good tool to communicate with the public. We haven't used it that way. And so that's an experiment, but that's something that we could walk through the process of what that might look like. I would say that the most important thing is that this tool is designed to increase transparency. So because it increases transparency, it makes it very clear what the steps you followed are. There's also ways to consider public input because that's the hard part. What do you do with public input? And you have all of these social categories, or you have different ways to collect different types of knowledge. And this complex of a tool, it's actually fairly simple. This dynamic of a tool actually gives you a place to consider that input somewhere in the process.
You mentioned, or Sebastian, you had a slide that you use this this tool with the Duluth, was it natural areas?
Uh,
I just
yeah,
wondered
the-
how that process went. I mean, it was obviously different. Well, maybe it did involve dredge material, I don't know, but it didn't. Okay, so I just wondered what the comparison was with that experience.
Yeah, I mean, we had a group of stakeholders for it's the natural resources management program plan for the city of Duluth. And yeah, we were able to compare an extensive, like it was like 30 some projects that program was considering. And we actually developed a pretty much totally new list of criteria for comparison. And yeah, it informed their prioritization plan. I think, they have a new manager, Kate Kubiak, but this was right at the tail end of Diane Desitel's time there. So yeah, I think that went pretty well.
It was similar in that it kind of broke down the decision into different categories and then created criteria within each category. So it was designed to be as transparent and as collaborative.
Go ahead, Nancy.
Hi. So this may not be as relevant in other harbors and areas around the Great Lakes, but in this particular AOC and harbor, tribes and tribal agencies are major partners. I don't like to use the word stakeholders, but obviously very much involved in planning and restoration, remediation, et cetera. One element that seemed to be missing in your social benefits buckets was a factor related to cultural preservation or cultural enhancement. And I think that's something that we might want to consider. And that might become more apparent when I talk a little bit about the project that we have kind of in early stages right now.
Oh, absolutely. That's probably a line we'll just add today. I mean, because, so when we started this project, we weren't even working on the Wild Rice project yet. So yeah, we're learning as we go. Go ahead, Paul.
I have a question. I really like the framework, beneficial use. Nonetheless, how does it accommodate anticipated, perhaps negative impacts that this might have? Does it accommodate that? And if so, how?
Yeah, I mean, I would say that some of the criteria are about longer term considerations. I think to reflect it in the scoring, it's a matter of having those long-term considerations being considered and then reflected in what a scoring value is. So if it's, if some project in the longer term is, I don't think an agency would approve something like that, but if it's deemed to have a detrimental effect on some sort of habitat, then that habitat score for quality or quantity would be a low one, right? And then you would have to note it in the profile and you would see why it has a low score and be able to refer back to the fact that people project it could have a negative impact. And I think it would, be case by case for each of the criteria. Does that make sense?
It doesn't for me, but I'm just a novice at this. I'm asking more, is it reflected in, you said this is an evaluative tool. And it's tied to sort of an economic projection. And so if there are anticipated or potential detrimental effects, does that have economic projection in this model?
So that's a good question. I believe that negative impacts would be collected somewhere in the worksheets. Because you can,
Somewhere, but
in the worksheets, because that you can talk about the direction and the, is it positive or is it a negative change? Is it something that will have a small effect or a big effect? That's where you would be capturing that. Because, are you thinking specifically of exposure questions?
That would be one example.
So exposure to contamination is one of the criteria. And so you would mark that as something negative, and that's something that mathematically would become a lower score. So it is considered, it's just, it's not considered in, it doesn't have its own box, but that doesn't mean that it's not in the tools somewhere.
Thank you.
And we have a question online?
Yeah, it's just a follow-up, I think, on the same topic. It looks like some of the definitions in the individual worksheets capture potential adverse effects, even if it doesn't explicitly assign a negative value that Willis was asking about earlier. For example, this person says in the biophysical environment, there are options to see habitat loss or gain, and they just note, it seems somewhat flexible.
Right. Thank you, whoever said that.